It's the part 2 of the video series, and last video I had spoken about the very basics of OOPS. Alright, and I had told you that I would be discussing these 4 features in a more specific nature. So let's get right on to it. The first one's okay, before all of that, I hope you're familiar with the fact that OOPS is actually a language which is modularized. Is actually modularized. Now, what do you mean modularized? Is that the whole program is written in modules. Okay, like I stated in the previous video, we spoke about different classes being different segments, but are interconnected. So the term for that is modularized. Alright, so you may hear this a lot of times, or you may, when you go through the notes, this basically means that. Okay, you may come across this word. Okay, so the next thing that you need to know before you get into the more details of the features is what exactly is a class in brief. Alright, because class is a vast subject to cover, and it's beyond the scope of this particular video. So I can just explain to you in brief. So class is basically a data type in a layman's term, or to simplify, it's a data type which consists of both functions and variables. Alright, now it is also in more sophisticated terms, it's also defined as a blueprint or a prototype or a template for a module. Okay, now blueprint in the sense it's like a word or a keyword, like you say whenever you declare a class, you will say class and then the class name, for example ABC. Yeah, so this becomes your data type. Alright, and when you declare it in the main function, int main or so on and so forth, you will declare the object with respect to the same name as your class. Alright, now this is your object declaration, which we will come to later stages. But basically what you need to know is that it's a template for a module. Okay, it represents a module, right? So in the class you'll have your variables and your functions. So this is a module, alright, and the class that you write is a blueprint or a prototype for all of these. Like, it represents all of these things when you declare it. Okay, much like a structure, as again I said in the previous video. Okay, now let's come to the basics of or the features of OOPS. Now these features that we will be discussing are basically the properties of OOPS. Okay, like to make you understand, my property is that I'm a girl and I have 10 fingers in hands and 10 toe fingers. These are my properties, these are my features. Okay, I have 2 eyes and a nose. So similarly, there are features of OOPS that I just listed, in the previous video, which are the following. So that's what it basically means. I mean, it has features, and these are properties which make OOPS what it is, basically. Alright, so beginning with the first one, which is data encapsulation. Let me see if I can fit in here. Okay, so first one is data encapsulation. Yeah, now what do you mean by the word encapsulation? Now you know the word capsule, right? What does a capsule do? It contains the medicine, and it's closed together and it's capsulated. That whole thing is called capsules, but inside it there are so many medicines or whatever things. So it's capsuled in a cap. I mean, it's capsuled in a tablet, or as you would like to put it. The same thing applies here, okay? What does it encapsulate? Encapsulate is a verb, okay? Encapsulate, to encapsulate something means to bind something. Okay, so what is it encapsulating? It's encapsulating data. Okay, that's why it's called encapsulation. Alright, now what does encapsulation mean is, it means information hiding or data hiding. Yeah. Now what is this information or data hiding that you're talking about? Now in classes you have the liberty to hide or make a certain data type or data function public, private, or protected. So that is encapsulating the data from other parts of your program. Okay, that means that inside the class, whatever you declare, if it's under the name of private, that means no other class in the whole universe can access any of those data. Okay, suppose you have this class, yeah, and you have some functions in it, say print. Okay, you've user defined a state or a function to print something, and this is inside the class A. Okay, now somewhere in the world you're declaring a class B. All right, this has some functions, blah blah blah. Now you know that in C++ you have the liberty to, you know, declare call functions of one class to another and make use of all of that. But if this is in private, this class cannot access it. Okay, I mean, there are ways to access it, but we will learn about that later. I'm just trying to make it clear what exactly you mean by information hiding or data hiding. Okay, another way to define data encapsulation would be that it is an interface between object and the program. Okay, now when you declare your class and then you call it in the main function, what you're doing is that you're calling the class name and the object. Yeah, so what exactly is, you're encapsulating this, right? Now when you're calling this object, it's literally accessing everything that's encapsulated. Yeah, so this feature basically tells you that it's like, you know, communicating between the object and the class. Okay, this property is called encapsulation. But mainly encapsulation means hiding of data, or, you know, information hiding. Okay, your next feature is abstraction. Now abstraction cannot happen without encapsulation. I mean, abstraction is something that generates, you know, because of abstraction only there's encapsulation. Okay, they're both interconnected. Now abstraction means implementation of variables. Okay, I'm just going to write that, implementation of variables without knowing it's working. Okay, what do you mean by this? Now taking an example of the most simplest function ever, cout. What does cout do? It prints. Okay, now we know that this is an inbuilt function, right? But what we don't know is how it works, right? I mean, you just know that you have, when you declare cout, it's going to display something. Yeah, so that is abstraction, because in the C code, or the language, I mean the main hardcore code for C, where all of these functions are defined, which is your iostream.h library, you don't know what's going on, right? Like, you don't know how this cout function is actually working inside, because what actually happens is when you declare the cout function, that whole code comes out. Yeah, so that's what it means, that the actual working of this function is hidden from you, and this is what means by abstraction. Okay, this is one of the most beautiful features, because when you're again, you take an example of, you know, sorting a variable. Yeah, so when you call the sorting variable or sorting function in the main function, you don't see how the algorithm is working, or how the, you know, how you have made the sorting happen. Okay, all you know is that when you run this, you get an output. And this is what abstraction is all about. I mean, it hides the actual working of hides the actual working from the user, which makes it more user friendly and makes it much easier to understand. Alright, so abstraction, like I said, abstraction and encapsulation are related, because when you're calling, see, abstraction ka example is when you say cout and then hello world. Yeah, so this is like a feature of abstraction ki yahan pe you don't know what's going on inside, but it's implementing this whole thing. And this cout is encapsulated or captured in a unit in a header file called iostream.h. Okay, so this is what you mean by abstraction and encapsulation and how they're related. Inheritance and polymorphism are comparatively very easy to understand, where inheritance basically means adapting or adopting to the functions or variables of a class into another. Okay, what I mean by that is that there's a base class, can also be called as the parent class, and then there's a derived class, which can also be called as a child class. Yeah, so what it does is that this child class inherits the qualities from its parent class. Okay, now what it means is that whatever functions or whatever variables are there in this can be inherited by this child, or it will apply to the child class. You can declare two different classes but inheriting the same thing. For example, in a real time example, there's a class called bird. All right, class called bird, and then there's a class called sparrow. Yeah, now sparrow, or okay, screw birds. I'll show you a better example because I like this one. I don't like the birds thing. Okay, there's a class called, say, mobiles. Okay, and then there's another class called iPhones. Alright, now iPhones is what? A mobile. Now it has the same features what a mobile does, like call, text, or perform certain basic functions, features, etc. It's all common to all phones. So it inherits the properties of this class, parent class, mobile, and iPhone itself has more added features which, you know, you can add. So basically inheritance means that apart from having your own features, you can inherit the basic features from your parent class. Alright, this is what inheritance means. And another thing is what? Last one is your polymorphism. Yeah. What is polymorphism? Okay, poly means many. Morphism means form. So when you put it together, many forms. What it means is that one function has different forms, can perform different forms, can perform different tasks. Okay, same thing, different tasks with the same name. All right, what it means is that, okay, a real-time example, that you are different when you're in, you are the same person, yeah, but you're different when you're in class, you're different when you're in a bus, you're different when you're at home, you're different when you go out. See, but it's the same person, right? So that is called polymorphism. Okay, now when you apply it to C++ and coding, what it means is that one function called add can either have, you know, 2 parameters, or add can have 3 different parameters. Yeah, so this is what you mean by polymorphism, basic structure. Yeah, again, polymorphism helps you to implement a function in different way. Yeah. Now you come to the last. Okay, there are 2 other things that you need to know. One is dynamic binding, and another one is message passing. Okay, I'll explain message passing in very brief because it's very simple. Message passing is basically passing the values to a function and then communicating with class. So when you've declared a class and you've declared a function, so in function you put parameters, right? So those parameters, when you are passing the value from the main function, that's basically your message passing. Okay, suppose there's print. Yeah, okay, better add. So when you're adding, you're sending 2 parameters like 5 or 6. These are your messages sent to your class. So this is what you call message passing. I'll cover dynamic binding in the next video.